So if we're moving on here, this is going to be page 467. We have the binary search of an array. And the binary comes from how it is we think about our data set as we're going through. So remember, with binary, it's one or the other, right? It's on or off. There are only two values here. So what we're saying is, this search is binary because we take the length of our array and we cut it in two. So again, here on 467, as you can see right here, this is the pseudocode for that function. It is not a secret how these work. We are literally giving to you the code. What we really want to stress here is why this works and how this works and what you might do to apply this to your data. So what the pseudocode here on 467 is saying is we have whatever our search string in this case is that we are going to search our array for. Let's say we've got an alphabetical list of names and we are going to look for Herbert because it's a weird name. For any of you Herberts out there, I apologize. It's a unique name. For the rest of us, maybe not. So we're going to say Herbert. And I know I've got names that start with 26 letters of the alphabet. So rather than start at, Aardvarko and go to Aardvark and go traversing through the array from element 0, which is going to take a long time before I even get to the H's in my array, I don't want to waste that much time. So what I'm going to do is take my lowest element, and so 0, add my highest element, however many that is, and divide it by 2. So what that does is it takes my array and it folds it in half. Now I'm going to check that middle value against my search value. So Herbert is less than whatever in the middle would be Marjorie. So I know that my array now from Marjorie all the way to Zydeco can just be thrown away. I don't need to search that portion of the array anymore, and I stop thinking about it. So now I take from Marjorie to Aardvark, and I cut that in half. And I say, okay, is Herbert greater than or less than whatever the middle result of that would be? And it's greater than, right? Because we would be someplace in the, D? So let's say Dustin or something. So now I take those halves again. So I only check from Dustin to Marjorie. Now I cut that in half and I get someplace close to Herbert. You can see how quickly it is I start removing vast portions of my array. And the binary search is hyper efficient. We can take something like hundreds of millions of data points in an array and only do a couple of dozen individual searches before we land on whatever our search string is. That is just an exponential reduction in the amount of time it takes for us to do some of these big data operations. So we've got a couple of explainers in here. What I'll tell you is you do have access to the video note there, which can do graphics, which I don't do. But essentially, again, what we're doing is we're taking the array and we're cutting it in half, hence the binary. So then we check either the last half or the first half based on our search. Then we cut it in half again, and we check the last half or the first half based on our search. Then we cut it in half again. And just think about, the reduction there in values. If I have 100 elements in my array, the second search is only 50. The third search is only 25. The fourth search is only 12 and a half. And look at how small that data sets get very quickly. So the binary search is incredibly fast. However, it relies on one of the other components we need here from inside the chapter. The elements in our array, the data set, has to be in order. And that order can either be from greatest to least or least to greatest, but it needs to be ordered. So what we need to do next is sort on that data.